What is horizontal asymptote? Well, I've been asked this question so many times, and so I've decided to give you a set of videos on horizontal asymptotes. So I'll explain you what is horizontal asymptote, what and how we can find it, right? So I'll have 2 or 3 videos on this. So this one, let's just try to see some examples where we can appreciate what really horizontal asymptote is. So I'll just draw some functions, the graph of some functions, so that you can see what horizontal asymptote is and what we are looking into really. And then we'll try to understand those horizontal asymptotes. Now this is an interesting graph of 1 over x, right? So if you have a function like this, you're familiar with this. And we could flip it and this could become like this, and that is 1 over x squared, for example. And if we can have graph like this also. This is 1 over x squared plus 1 type of a graph. Now, and you have also seen graph of exponential functions, which is kind of like this, right? Well, I haven't drawn arrows for others, but they all extend from minus infinity to plus infinity, with sometimes a discontinuity in between, correct? So to be very specific, these are graphs of functions like 1 over x, and this is like 1 over x squared. This is kind of 1 over, we can write x squared plus 1. This could be graph of exponential function, say 2 to the power of x, right? Now, what we notice here is one important thing, that is, as x approaches infinity, plus or minus, the function approaches a fixed value, especially in the first 3 cases. Now, here, for example, we see as we approach minus infinity, the function approaches 0, right? It approaches 0, but from the negative side. Now here it approaches 0 from positive side. In these 2 cases also, it approaches 0 from positive side. And so we say that this line, which is the x-axis, forms a horizontal asymptote. So basically what we see here is, as x approaches minus infinity, we find that y approaches 0. So it approaches 0, but it is slightly negative. So I'll put this dash here as negative, saying that my function is approaching 0 from the negative side, okay? Now the value of the function is 0. But the thing is, it is never 0. It is always approaching a value. 0 is a value, correct? So whenever we have a situation that for an extreme value of x, if the function is approaching a value, we say there is a horizontal asymptote which is being approached. And the equation for horizontal asymptote will be the value being approached. We say y equals to 0. So y equals to 0 becomes the equation for horizontal asymptote in this particular case, right? Now, if you see this function, what happens when x approaches positive infinity? When x approaches positive infinity, in this case, we again see that y approaches 0. But this time, it is slightly positive, right? It is still positive. It is very, very small, close to 0, but positive. Still, it is approaching a value. 0 is a value. And we say, well, the horizontal asymptote is y equals to 0. The value which a function is approaching, but is never there, right? In these examples, what you find is that as x approaches minus infinity, y approaches 0, but from the positive side. Do you see that? And the horizontal asymptote is y equals to 0. The value function is approaching. And here, as x approaches minus infinity, we have a horizontal asymptote, which is y equals to 0. But in this particular case, as x approaches positive infinity, then the function is approaching infinity itself. So there is no horizontal asymptote on the right side, but there is one on the left side. On the left side, when x approaches minus infinity, so what we see here is, when x approaches minus infinity, the function approaches the value 0 from the positive side, slightly positive, right, above the x-axis. And therefore, the horizontal asymptote here is the value it approaches, which is y equals to 0. Remember, y equals to 0 is the equation of x-axis. Remember that, right? So y equals to 0 is, remember, x-axis equation, right? Well, in all the cases, you will not have horizontal asymptote kind of similar. There could be cases which you can come across, which we'll soon discuss in the next video, where you may have different horizontal asymptotes. For example, we may have a function like this. So in this particular case, you will find that the function is approaching different values. For example, this function may be approaching plus 1 when x approaches infinity and minus 1 when x approaches minus infinity. So here you may see that when x approaches minus infinity, y approaches, let us say this value is minus 1 and this is plus 1. So y approaches minus 1. So in this case, your horizontal asymptote will be y equals to minus 1. But when x approaches plus infinity, y also approaches a different value, but that is 1. Right? It may be going under it. We'll write 1 minus, sticking with our nomenclature. Right? We'll see how this nomenclature is very helpful in coming videos. So when x approaches positive infinity, y approaches 1, a value. So therefore, we have another horizontal asymptote, and this time y equals to 1 is your horizontal asymptote. So a function can have more than one horizontal asymptote depending on where the function approaches when x has an extreme value. So we are always checking for x approaching minus or plus infinity and checking for the y value. If y is approaching a particular value, then it has a horizontal asymptote, otherwise not. So in these situations, wherever we see that as x approaches positive infinity or negative infinity and y approaches a fixed value, we say a horizontal asymptote exists. And the equation of the horizontal asymptote is always y equals to the value being approached, right? So in general, what I can write here as for horizontal asymptote, that if, let me write it here, in general, if x is approaching positive infinity and y approaches a value a, then horizontal asymptote is y equals to a. If x approaches negative infinity and y approaches a value b, then horizontal asymptote will be y equals to b, right? And as you have seen here with the examples, that a function can have more than one horizontal asymptote, correct? As in this case, correct? And second, when we are talking about horizontal asymptotes, we should keep in mind whether it is over the horizontal asymptote or under it, right? And we'll also see examples where the function will actually cross the horizontal asymptote also. So those are interesting cases which we will discuss in the following videos. But I think with the help of this video, you have clear idea of what, after all, horizontal asymptote is, right? It is just a value which the function is trying to approach as x approaches infinity on the extreme sides, both extreme sides of the x-axis, correct? So I hope with this knowledge we'll move on to the next few videos and try to find out how to calculate the equation of line or how to find a horizontal asymptote given a function. Okay, thank you and all the best.